So yeah, hello everyone. My name is Sergei. I'm grad student at Marcus Group, and today I want to make the talk on the download and installation procedure for Perturbo, as well as like overall introduce the general infrastructure of the Perturbo, what useful our packages you have, some tools, and so on. So in this talk, I'll repeat the general workflow of the Perturbo. We'll go through the website, which actually in case of Perturbo is very useful tool. I'll discuss the general download and installation procedure, as well as the short introduction of the Perturbo-py, very useful package related to the Perturbo. And then we'll finish with usage of the Docker containers, which we'll use during this workshop and where you run all of the programs. So I want to start from the repetition of the Perturbo workflow because, yeah, we'll work with it during these 2 days. Basically, it consists of several parts. First one is the supplementary calculations from the quantum espresso, which help us to obtain all of the supplementary information about the electrons, phonons, and which we need to use during the calculations which we use for the Perturbo. Second, very important part is the executable file, which we call qtper.x, and this file basically computes the electron phonon matrix elements in the one-year basis with the usage of these quantum espresso files. And this APR file is the key file for the Perturbo because all of the Perturbo calculations, all of the calculations of like any physical characteristic require to hang these files calculated on the basis of this quantum espresso supplementary files. Second executable which you have in the package of Perturbo is Perturbo.x. And this is the core executable of Perturbo, which basically performs all of the calculations for different calculation modes and which actually calculates all of the physical characteristics which we're interested in on the basis of these APR files and some our input files. Finally, we have package which is called Perturbo-py, which we will discuss separately. We'll have the separate session on it. But basically, it makes the post-processing of the Perturbo output files. It helps us to the import all of the output of the Perturbo in the Python, and then work with it easily, make some plots, and doing some calculations inside of the Python. And the first tool which I want to discuss with you is the Perturbo website. So basically, let's go just there. It's accessible by this link, perturbo-code.github.io. And we have lots of sections here. So let's go them just one by one. So here you have the menu. Where you see all of the let's also let's go to download installation. So basically here describe all of the installation procedure, which we will discuss separately, but you also can find pretty detailed tutorial on the installation procedure for several scenarios here. You can find all of related publications which mentioned Perturbo, which cited Perturbo, or some publications related to it. Also here you have lots of tutorials on the different calculation modes, as well as tutorials related to the pipeline from the SCF and our quantum espresso calculations to the Perturbo and obtaining the APR files. Set of some our examples. Here you can find the information about the previous workshops with all of the videos and the slides. And obviously for this workshop, also all of the slides and the recording will be available on this page shortly after the workshop, I think like in a week or two. Here you can find some information specific to different platforms. For example, here you can find the installation usage of the Perturbo for the Perlmutter supercomputer from the NERSC for the GPU and CPU compilations, as well as information on the Docker containers, which we'll discuss briefly with you. And additionally, some utilities. So Perturbo-py, which I mentioned earlier. Input generation, which is helpful tool, which we will discuss during the Perturbo-py section, and the interactive workflow, which may be the most interesting thing on the website. So basically, because the Perturbo workflow is pretty complicated and it requires several steps in many cases, we developed this interactive workflow, which basically can help you to understand how exactly provide the type of calculation which you're interested in. So for example, here on this workflow, you can just like choose what type of calculations you want to run. For example, we can choose this one, and you see, so it's like calculation mode transmag RTA, and it computes the phonon limited conductivity and carrier mobility using relaxation time approximation with magnetic field. And you see all required files, which you also can tap and see information about this file, as well as the output files which predicted to have. You also have the template of the input file, which you can use in your calculations. Here define the mandatory and some optional parameters. Also on this web page, you see the release notes, which can be helpful because, I mean, it's also provides some information of the compatibility with different versions of Quantum Espresso, which is very important in case of the Perturbo, because Perturbo used the Quantum Espresso calculations and they're required to run Perturbo properly. As well as some information on the input parameters, both for Quantum Espresso, Q2Per.x and Perturbo.x. Yeah, so that's on the web page. So yeah, use it actively, and it's actually very, very helpful for cases of the just usage of the Perturbo, or even in the case if you want to develop some part of a Perturbo by yourself. If you wanted to add something for yourself, it's actually also very, very helpful. So that's on the web page. Yeah, now we can move to the installation of a Perturbo from scratch. So basically, for correct work of the Perturbo, you need to install several additional packages. It's the package which called HDF5. It's basically the specialized package for the storing the data, which was developed especially for the scientific data. And two our packages is the Quantum Espresso, which I talked a lot about, and 1U90, which now you can install inside of Quantum Espresso, which help us a lot to actually present the data in the direct space. So important thing to mention here is that installation of all of these packages is severely machine dependent. So it's really depend on which machine do you use, which type of compilers do you use, which option do you need to use. So the only information which I present here is like some general things which always should be included in the pipeline. So in case of installation of HDF5, you just need to download the zip archive, unpack it, go to a folder, and configure it with like this set of the options. So these three options, they're just required. So you should enable HDF5 to work parallel with the files in order to speed up it. You need to also make this, to add this flag in order to be able to like actually compile it with some Fortran libraries and to make the libs which then Quantum Espresso will be able to connect with. For Quantum Espresso, it's also downloading from the GitLab folder of the Quantum Espresso, unpack it and configure and make these 4 executables for the which will be required for the pipeline. So it's PW, PHPP, and 1U90 files. As I said, be very accurate with this installation procedure, just because it strongly depends on which supercomputer do you use. Do you try to use it on your personal computer, which is ordinarily not advised, just because Quantum Espresso calculations can be pretty heavy and it's better to use it on the supercomputer. So yeah, always follow the recommendations for your machine and for your type of the compilers. On the installation of the Perturbo, it contains several steps. So basically, the first one is you need to fill out the form. So this form, this is the form how it looks like. You're able to find this form on the Perturbo web page. So basically, if you just go to this download tab, you also open this form. Basically, here you need to fill out your email, name, institute, country, and like the topics which you're interested in, and so on. And basically, the most very important thing here is to add your GitHub username. Even though it's not obligatory, it will help you a lot, because basically, if you do not write this in, we will just send you the zip archive with the code, which you will be able to use, but you will not be able to later obtain the update on the code when you make the new release. If you just add this username, basically you will be able to use the GitHub repo of the Perturbo, so this one. And it's actually very helpful to be here because we have lots of discussions from the users. We have issues tab where you can just open the issue and discuss some problems which you obtain during your work. And also here you obtain all of the versions of the code in the same pack, so all of the releases, all of the links to the documentations, all list of the features, and yeah, also for us, it's just like the main platform where we interact with the users between the workshops. So please, yeah, add this information on your GitHub and yeah, use the code. So when you download the code either from the GitHub repo, so just like tap code and copy it from the with the SSH option, you just clone it, go to a folder, choose the right config machine file. So basically in the folder Perturbo, you have the folder config, this one, and it has sets of the predefined make files for different compilers, for the i4 compilers, for GCC set of the compilers, and so on. You can choose whatever is suitable for you, which is suitable for your machine. In some cases, you need to change it a bit, but I would say that for Perturbo, installation procedure is the most straightforward among all of the packages, which I mentioned earlier. Important thing to mention here is that HDF5 is very, very important for the Perturbo. Basically, lots of files which used in the Perturbo related to HDF5 format. And yeah, please, if you didn't compile QuantEspresso with HDF5, compile Perturbo with it, and just like then run make procedure, and you'll be fine. Yeah, brief discussion of the output files. So basically, Perturbo has three formats of the output files. First one is YAML, classical output format for the programs, stores inputs and output for the Perturbo calculations. It can be easily read by high-level programming languages such as Python. It's pretty easy to understand and pretty easy to read. Very, very comfortable. In the cases, if you have like very, very complicated set of the information, for example, for the APR files, we use HDF5 format, which is specialized scientific format, and also which are able to read from the different languages such as Fortran, Julia, Python, and anything else as well. Also, we have some ASCII files. Mainly, it's some supplementary input files and some like temporary files, which Perturbo use. If you see the output files in the ASCII format, we have it just for the legacy reasons. So they have exactly the same data, which as well as our output files, HD5 or YAML. So it's not recommended to work with the ASCII files at all. And I mean, you don't need to interact with them with the output in this format at all. Next thing which I want to briefly discuss, because we'll have the separate session on this, is the Perturbo-py package. So basically, as I told, it's the package for post-processing and testing Perturbo. What's the main functionality of it? We can split it in two parts. First one is the just post-processing. So basically download all of the data which you obtained from Perturbo into the Python, making some plots, calculating some features, and so on. And another important thing is the test suite for Perturbo. So it's the way how you can run, how you can check that you installed Perturbo correctly, that you obtain correct values, and that you'll be able to use it in the correct way. And installation of it is pretty simple. So it's available on the PyPI, and it's recommended way to installation of a Perturbo-py. Another way is you can download it from the official GitHub of the Perturbo-py. It's open for everyone, so you don't need to fill out any forms. You just go to the GitHub page of the Perturbo-py and clone this repository and yeah, run pip install dot. Basically, that's all. And we also have the official website of the Perturbo-py. So with the documentation, you can just like find it in the search sources, and yeah, with all of the detailed tutorials as well on the how use Perturbo-py, how to correctly install it, and so on. And the last thing before we actually go to the hands-on session is the Docker usage. So as I told, installation of the Perturbo from scratch is pretty complicated procedure. You need to install several packages with very high accuracy. They severely depend on the machine which you install it in, and it's like pretty complicated. Just like try how to use Perturbo and obtain like the general flavor of this package. In order to avoid it, in order to be able to run some tests or like to make some kind of the simple place to work in, we developed these Docker containers, which you can use. So basically, what is it? If people don't work a lot with this system, Basically, Docker built a micro OS, which called image, which is lightweight and containing solely packages which you need to work with. So, for example, in our case, it's the this Docker contain like very, very small Ubuntu, and inside of it, it has HDF5, QE, Vanilla90, and Perturbo packages. And more on the Docker usage you can find on the GitHub of our workshop. And now let's basically go to the hands-on session. So you can find this hands-on session on the GitHub link, which I think we provided in the emails. And yeah, if not, just like to go there, you can go to the Perturbo-code, yeah, link provided in the chat. Amazing. So yeah, and here you have the tutorial information on the how to work with the Docker containers. And yeah, I can show you. So basically what you need to do is, first of all, you need to start the Docker desktop application. So this is basically the main program of the Docker, which you're able to run, which help you to actually work with your containers, which should just work when you use the container. Now we can go to the terminal. I'll split the screens probably like this. Yeah. Idea. Great. And oops, yeah, this one is good, and this one is good as well. Amazing. So yeah, let's talk a bit about the containers overall. So as I told, basically you can describe the Docker container as a micro OS, which is not exactly true. So important difference between them is that, like in case of actually the virtual machines which you run on your computer, is that basically all of them are strictly independent from each other. So you have infrastructure, you have hypervisor, which is defined like interaction between the operating systems, and each of them are solely separated. Docker containers starts on the base of the host operating system and use their kernel in order to run correctly. And you have like lots of very, very small containerized applications inside of each Docker container. So yeah, as I said, basically in our case, this small container contained a small Ubuntu system, HDF5, Quantum Espresso, Vanilla90 inside of Quantum Espresso, and the Perturbo package. So yeah, basic concepts of the Docker, which you need to understand, is the image and the container. And I think the clearest way how to explain it is the relation between the class and the instance of a class in the programming languages. So basically, image is definition of a class, it's definition of the system. So it's just like maintain all of the important features of the system which you work with and all of the definition of the packages. Container is basically instance of this image. It's exactly the entity which you work with, which you run, where you run your programs. And another thing related to discuss is the volumes. So basically, volumes is the feature which help you to run your programs inside of the container or to obtain some files in the container and then work with them in your host operating system. So basically, volumes connect the folder in your operating system and inside the Docker, and you can easily move files back and forth between of them. I will show you later how it works. So now, when you run the Docker application on your computer, when you installed it, you basically can just like type Docker in the terminal, and you will see all of these commands from the Docker. So like all of the important information on this, like Docker run, exact PS list of the containers, how to basically all of the help information which you can use. I would say that Docker documentation is very helpful. It's very detailed. So yeah, and Docker community is very, very helpful and very friendly. So yeah, ask them any questions if you have. It's pretty easy to find the information on it. So yeah, if you type Docker images in the terminal, another thing is that you see, okay, let's make this here. Amazing, yeah. If you type Docker images, what you will see the several lines. It depends on do you have any images or not. In my case, we have. So you see the repository from where it was downloaded. So in our case, repository called Perturbo. Like Perturbo is the user, and like this is the user, and this is the name of exactly repository for this user. We have the tag. So tag is the type of the container which you have. In our case, containers, tags of a container related to the type of a compiler which we used. So is it ifort with the MPI option? Is it GCC with the MPI OpenMP option or something like that? Image ID, it's just unique tag of this container and when it was created. And the size, obviously, as well. As you can see, the sizes vary significantly. And yeah, I'll talk about it a bit later. So if you want to obtain the Docker image on your computer, if you need to do it, you basically can download them from the Docker Hub of the Perturbo. So Docker Hub is a special place where you can find the Docker containers where people share them between each other. So this is the web page of the Perturbo. And here you can choose the text which you're interested in. So you can go to the text and choose a text which is interested for you. Which text to choose? Because there are plenty of them. So it depends on your machine. Several important advices. First of all, first important thing to mention, you always need to use containers with the number 3.0 inside, because basically this means that this container contain the last version of the Perturbo. So choose among them, because I mean, like, previous versions of a container may contain only like the old versions of a Perturbo, which is not useful right now. Second thing, these containers with the IFX in the name. So IFX, IFX MPI, and so on. Basically, what is IFX? IFX is the new type of Fortran compiler developed by the Intel. This is relatively new, so they're developing it for last several years instead of the classical Intel compilers, and they are not very stable right now. And some packages, as Quantum Espresso, for example, HDF5, does not work with them very well still. So I mean, like, all of this, the compilers themselves develop, and the work of the packages with this compiler develop as well. So they does not work very stably, and I will not advise them, honestly. In case if you have the Intel chip or AMD chip in your computer, it's generally advised to download the packages with the ifort in the name, like containers with ifort in the name, like ifort MPI or ifort 3.0 or ifort OpenMP 3.0, whatever you want to choose. With the exception of the Mac computers on the Intel chips. So because Apple finished their interaction with the Intel on the developing the laptops, Intel does not care about this type of machines at all. And as a result, there are lots of problems of running many applications on this type of the computers. So if you have the Mac with the Intel chip inside, please use GCC compilers. GCC compiled containers like GCC MPI 3.0 or ideally GCC OpenMP 3.0. It's the most stable version for the case of the Intel or AMD chips in your Mac. For everyone else, for people who use Linux, for people who use Mac OS, and for people who use the last like MacBooks with the M series chips, please use GCC. Please use containers with GCC in the name, so GCC OpenMP, MPI, or just like GCC. It depends on your preference. I run like any of them, so I can choose any of them. In order to download them, what you need to do is to just copy this command. Copy and go there. So Docker pull, it means like download, please, this image from the Docker Hub, and this is exactly linked to them. Just type it. Hello. Yep. Okay. So in my case, downloading procedure is very easy, just because I mean, like, I basically already have this container. In case if you download it from scratch, it will take some time, but only not very long. So with some exceptions, as you can see, if you're trying to download the ifort type of the container on the market, it's like 21 gigabytes. So it's pretty huge. So yeah, be accurate with your choice. Yeah. Okay, so when we downloaded this image, when we have it on our machine, what next we can do? Let's turn here. By the way, if you have any questions, you can ask. Yeah, because I mean, like, it's important during the hands-on session, actually go through the hands-on.
The ifort was still 20 gigabytes.
Even on the Intel. Okay, so it's like it's pretty heavy by itself. Yeah.
I'm never get Docker itself to work. I enabled like the virtualization of BIOS. I can't turn on the virtual machine platform on Windows anymore. Are you aware of any reasons that would be happening?
Like on the just like run the Docker itself?
Yeah.
Oh, okay, okay. Yeah, I mean,
I did it on a Linux subsystem. Because we didn't want to do, I think that there's like a specific Docker for Windows to download.
yeah, so that's important things to mention also out loud. So the point is that like basically Docker system as itself based on the Linux system. And it's like naturally it works very well on the Linux on the or Mac OS. In case of Windows, you need to, yeah, accurately download like specific Windows version of Docker to work with. And it's pretty tricky to do, and yeah, that's true. Just because I mean, like, yeah, that all like Docker based on the Intel and work Docker based on the Linux and works with Linux in the most natural way. So yeah, basically, when you download your image, you can run the image and just in order to basically run the container. So how you can do it? You can basically download this. You can copy this command and type it into the terminal. So what's here? Let's go from the start. So Docker runs basically run the container. V is for the volume. So basically, this is the connection between your host system and the Docker image itself. So on the left, you need to add the path from your machine. So basically what I will do, I just like open my documents, I go to work, I choose the folder with the workshop and just copy the path. So just like copy the path of this folder, go back to the terminal, delete this part and copy this path. So this is basically my path inside of my host system, inside of my macOS. On the right is the name of the folder to which it will be connected with inside of the Docker container. Then you have like this header name, which just like help you to understand like what's like, which we will see during the usage of the container. IT means interactive. So it basically means like run the container and put me inside of this container. Do not like run it silently. This option RM basically remove the container after you exit from it, just not to occupy the space. Name of the image which you run, and this is the name of the image which you use. So I will, instead of ifort, use GCC just because it's better for my system. Enter, and here we are. So we're inside of Docker already. So you can type us, and you see this like folder workshop. If you type pvd, you will see this folder. So here we go. And if you go to the workshop folder, you see all the files related to the hands-on sessions and related to the to a workshop. And for example, if I want to make the file here, I just type touch file one OS, and I basically see this file. If I go back to my host machine and go to this folder, I also see that this file exists. So this is the thing. Volume help us to like basically without any issues, like work with the same set of the files inside of our host system and inside of the image. And for example, if I rename this file here, I also see it inside of the Docker container. And if I RAM it, I will RAM it also from the both places at the same time. File. And I don't see here it as well. Okay, so here. Good. So yeah, inside of it, we have already compiled Content Press, so we have already compiled Perturbo, and you can run everything inside of this container. So if you just type perturbo.txt, you see that this starts, but I mean like it's compiled in a serial multi-threaded version, and it's running in my case on 12 processor cores. So yeah, we didn't provide any input, so that's why it doesn't produce any output as well. And yeah, just interrupt it by Ctrl+C. Amazing. So what we can do next, basically, is that what you can do is to run the test inside of your machine. So as I said, tests are important in case of the Perturbo just because it's like contain lots of different system interactions with each other. It contains the usage of the quantum expressor files and so on. So it's important to check that it works accurately. How you can do it in this case? You can go to the folder optimal packages, quantum expressor 7.3, Perturbo, tests. So this is the folder which is dedicated specifically to Perturbo tests, and here you have all the information related to it. In order to make the basic run of the tests, I'll talk about the tests later in the specified Perturbo-Pi session, but in order to make the tests, what you should do, you basically need to provide some basic information on the how to run the executables. So what I mean, copy the specific file which called config machine, turbo config machine.yaml. So basically, this is the specific folder where you should have the information. It's a folder where you should have this YAML file which provides the information on how to run the Perturbo, and it should be called just config machine.yaml. And there are like several versions of it which you can use. So we could let's just copy this file and open it. Config machine.yaml. What we have here? We have several things. So first one is the scratch folder. So where you should save all of the temporary file, where all the temporary files will be saved during the run of the tests, and computational information. So like what commands should be run before execution of the Perturbo, some like parameters of the OpenMP, for example, and how to run the Perturbo to text. So let's just change this command, delete all of this information on the rest run, and some other things. And let's also remove this because you don't need to load the Perturbo inside of the container. It's already loaded by itself. Amazing. So save this. Okay. And now basically one thing which you need to do is just type the command run tests with the option S. So S will just like show the tests while they run. Type enter, and you see how tests are running. And you see that like they're running successfully. So yeah, that's the basic things on the testing. Also, the test suite part of the Perturbo-Pi is pretty developed. There are lots of options. There are lots of things to use inside, but I'll talk about them a bit later. The most important thing is that which you need to see now is that basically, even though the personal computer is not so powerful in comparison with the supercomputers, for some simple calculations, Docker is a suitable option. You need to spend some time in order to understand like the general philosophy of the Docker and how to install it in case of your machine. But if you're able to do it, you're basically able to run Perturbo executables very, very easily when you just download this image and work with it. And obtain some, at least like very simple results and obtain like just general flavor of how to use this package and how it can be helpful in your case. Yeah, so that's basically all what I wanted to say during this session. Yeah, and we can wait until the test will be passed, while I'll be happy to answer any questions which you have. Thank you a lot.